Now, here we were discussing that what is the classification of stochastic processes. So one important stochastic process is a counting stochastic process. Counting stochastic process, how it is defined. So NT, let's say this is some stochastic process, okay, NT. Now NTS will yield some integer values which are always increasing, okay. For some t less than 0, then the process becomes a counting stochastic process. It will be having a discrete values. So now if you represent this as counting stochastic process in terms of a graph, you can say that S1, S2, S3, S4 are the 4 points, and T is a function, and X1, X2, X3 for a 4 instance. Now the values are always increasing of this function. So this is called a counting stochastic process. Now the other is a renewal process. Renewal process. Renewal process is nothing but a counting process where your inter-arrival times are independent. Okay? Or in other terms, we can say that the discrete time, that is the x, where your x1, x2, say there are the random variables x1, x2, they are the functions, they all yield are identically distributed and they are the non-negative random variables. Then the process becomes a renewal process. And the last and one of the most important is your stationary process. What is a condition where your stochastic process becomes a stationary process? So again, let's say that x t, where t belongs to t, is some stochastic process. Now this stochastic process is said to be stationary if for n greater than equal to 1. Okay, nth order joint CDF. What was the nth order? F x comma t is equal to p x t1 is equal to x1, so on, x tn less than equal to xn. This nth distribution function satisfies a condition. This function satisfies a condition f x comma t is equal to f x comma t plus tau. That means that if t varies, your time is varying, but still the function remains the same. That is called your stationary process or a strictly stationary process. That means if you add a tau as some vector to all the values of a parameter t, your function still remains the same. That is, the adding of a scalar does not have any impact on the existing function. Then the process is called as stationary process. Now, let's say this is your stationary process. Now, you are adding tau as scalar to t. No, it does not impact process, stochastic process. You can see here fxt, that is at t point, is the same process as xt plus tau. Then the process is called as a stationary process. Now, if we derive the mean and of this stationary process, what we will get? Let's see. See, let's say mu t is equal to E xt. This is defined as a mean. Now we know that the process is a stationary process. That means if you add some vector in it, it does not have any impact on the process. Say fxt is equal to fxt plus tau. Okay, this is a definition. This is nothing but a definition of stationary process. Stationary process. Okay, this is a definition here. Now, if we say that t here you're adding a scalar does not have any impact on t, so we can say that mu is equal to ex. Okay, or we can say why, because mu t is equal to mu for all t belongs to t, because changing the value of t does not have any impact on a process. That means the mean at instant t will be the same as at t plus tau. That means mu t should be equal to mu t plus tau. Okay, taking this definition as a reference, we say that mu is t is equal to mu when all t belongs to t. Okay, so here we can see that for a stationary process, the mean does not have any relationship with the time t. So for a stationary process, mean is time independent. This is how we define stationary processes. Now there is another type of stochastic process called as Markov process, and there are a few more types of stochastic processes, just like Markov and the Poisson process. Poisson. These two processes are very important because these lay the foundation stone for the queuing theory. I will take up these two processes in my separate session, because we need to go in depth of these two processes to understand the basics of a queuing theory and do the modeling for existing systems. So this was all about the basics of stochastic process. If you have any questions, reach me at gupta.anshu3@gmail.com, or you can drop me an email at gupta.anshu3@gmail.com. Till then, thanks.